Alright, good day, great then. So, welcome to our first lesson for advanced mathematics. So, before we start, let us start our discussion with this simple and short prayer. Alright, so I will lead the prayer already. So, let us bow our heads and feel the presence of the Lord. In the name of the Father, the Son, the Holy Spirit. Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joachim, and Saint Anne, and guardian angel, intercede for me, so that I may be deserved to be helped and saved today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, the Holy Spirit. Amen. So, again, good day, grade 10. So, I'm hoping that for this discussion, you will be listening and be ready for all the things that you will be hearing and you will be seeing in this lesson. And I hope that for this moment, you will be getting your journals beside you and take some notes for the important details that you will encounter within our lesson. So first and foremost, um, for your journal, again, I would like to remind that don't forget the time, the title of the lesson, and the reflections, and what are the things that you've learned in our lesson for today. So let us start with our lesson. So for today's lesson, our topic for today would be series and sequence, rather sequence and series. So if you heard sequence and series, what comes into your mind? Hmm? What comes into your mind when you say sequence and series? When you say sequence, it has order, right? If you say series, it has words. I need words. If you say series, it comes with a continuous subject or in a ordered form as well as the sequence. Sequence has a pattern, right? So for this sequence and series, I want you to think about of what are the things that we could see and we could learn about this topic, all right? So let's continue, all right? So let us continue. If we say sequence, um it is something like you can see in a pattern form, or either in the form of set of numbers or set of values, which could be formed in a lot of different uh, forms. So let us start by defining what is sequence and series. If you say sequence, it is an ordered list of numbers, right? That's the one I said a while ago. And when we say series, it's a value when you add up the terms of a sequence. So therefore, we could say that this series uh, would be related into this sequence. So later on, you will be knowing why is it like that. No, so also a sequence. A while ago, I already said what's sequence all about. No, so if we say sequence, it is a progression of numbers, or there is a continuous pattern that you could see in that kind of set. All right. So also, if we say a sequence, we could see if it is a arithmetic or in a geometric. All right. But in some cases, sequence could be found either of the two. All right. It um if we say in general terms, sequence could be found anywhere. But in this case, in our lesson for today, we'll be dealing sequence more likely in arithmetic and geometric. But first, again, we are in sequence and series. Now we have this series. Also, a series is a the totality or the sum of the numbers in a sequence. And also, we see this sign. If we see this sign, it is called as sigma. So most commonly, this sigma are used in research or thesis, most likely in the computational part in this chapter 3 of the research or thesis. No, when we have that kind of sign, we call it as sigma. If we say sigma, it is the sum of all sum. Again, it is the sum of all sum. So basically, if you have a sum of uh, two set, then the first set would be 1 plus 2. Then the sum of the first set would be 3. Then the second set would be 2 plus 3. It would be 5. Then the sum of the two sum would be, the first would be 3. Then the second would be 5. Then the sum of the sum would be 8. Then the summation of the two set is 8. That is summations, no? So I would like you to remember what is this symbol, no? And also, sequence. If we say sequence, it could be infinite or finite. So later on, we will be discovering some of these examples of how could we see whether if a sequence is infinite or finite, and as well as arithmetic or geometric, or neither of the two. All right. All right. So I am hoping that you are really listening and hoping to take down notes, or the notes that you will be seeing here in my slides. And for the next discussions, I'm hoping that you will get something on this lesson. All right. So to continue, all right. So let us try this sequence. All right. So we are to find the 10th term of the sequence. So what are we going to find? The term that we are going to find would be the 10th term of this sequence. So our sequence would be 2, 5, 8. So anybody from the class, if who would like to answer what would be the 10th term of this sequence? All right. So, I would like you to answer. No, I would like you to answer in our comment section here in live portion of our video. No, so I will be seeing and I will be checking right after this video. Most especially, the moment that you are watching this video, or right now, I'm also watching the video and I'm seeing who's entering or who's commenting in the comment section. All right, so please type on the comment section whether what is the 10th term of this 2, 5, 8. What is the 10th term of this sequence? So if we could get, or if we could see this sequence, we could see a, what we could see in this one, we could see a pattern, right? So right, so we have this kind of pattern. So what kind of pattern we could see in this kind of sequence? So let me see. All right, so there are 2, 5, 8. The 2 becomes 5, then the 5 becomes 8. It was added, yes, okay, it was added by how many? All right, comment down in the comment section. All right, so it was added by, sorry, pardon with my drawing, added by 3, right? So as well as with the second term of 5, it was added by 3 as well. So class, this is our first term, second term, the 5, and the third term, 8, and so on. So remember, the terms for each sequence is really important, for they have a specific reason and classification in the future discussions. No, so as you can see, all right. So let's go back. So if you can see here in our sequence, each term was added by 3, right? So if I will ask you again, what did we do? The first thing we did was to find the pattern, right? So after we find the pattern, we saw that the pattern of this sequence was to add up, right? So let me erase this ones first, all right? So after we add that one, what's next? Right? So the first one is to determine the pattern. So after we determine the pattern, we just saw that it was added or adding 3 to the previous numbers or in each term, right? So as we know that it was added to 3, what would you see? All right. Or rather, what do you see when it was added? No? Aside from it was added by 3, what did you see? What did you saw? We saw, right? So let me answer. So we saw that in each term, no? In each term, right? So the sum or rather the common in each pair term, no? Pair term. The first pair would be 2 and 5, right? So the second pair would be 5 and 8, right? So we could see in this common pair, or rather in this two pairs, uh, two pairs, we could see that they have what are the common to this pair? They have they have common difference. Yes, it was added, but how would you say, like, how would you describe these two pairs, right? So why would you say that it was difference, right? So if we could see that in this first pair we have 5 and it was subtracted by 2, right? So 5 minus 2, it would be simply 3, and as well as for the second pair it would be 8 minus 5 is equal to 3 as well. So if we will see, the common difference of these two pairs are 3, right? All right. So if they have the common difference already, we could say that by the second term we have the formula already. So we could how are we going to get the common difference? In order for us to get the common difference, it would be the second term, as you can see, no? The second term, or a sub 2 minus a sub 1, right? Is equal to what? The common difference, or the common difference here, right? Alright, so aside from this adding 3, it is known as the common difference. Alright, so as we continue to get this kind of pattern, as we establish or as we know what on how to get the common difference, we could now easily find the 10th term. So would anybody find the 10th term? Alright, so I'm seeing that there are some commenting already. I wonder. Alright, so uh, please put on the comment section. Remember, again, I am with you watching the video right now. Alright, so again, what would be the 10th term? Alright. Alright, so let us find the 10th term, alright? So the first term would be 2. The second term would be 5, 8. What's next? 11. What's next? 14, alright? So what's next? 17, alright? So 1, 2, 3, 4, 5, alright? Please wait, huh? Please wait. Alright, so what's next? 2, 5, 8, 11, 14, 17. Alright, so it is 1, 2, 3, 4, 5, 6. It's 6 already. What's next? It's 23. It's 27 already. What's the next? 26. 8. Next, 29. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us see. Alright. Alright. So if it is, oh, I'm sorry, this is, we should have at least 20, no? Alright, so it is 10 already. Then the 10th term, I'm sorry, the 10th term of this sequence would be 29. Alright, so to continue the pattern that we had, and the pattern that uh, know, we knew at the first place, is by getting the common difference, right? And with that, we already got our 10th term, alright? So to continue the pattern, to get the 10th term, so we have 2, 5, 8, 11, 14, 17, 20, 23, and 26. And what's next? The lastly is 29. So the 10th term, or 10th term, would be 29. Alright, so you're correct. Alright. So I am happy that uh, wondering that some of you are commenting right now, right? And some of you may be not commenting, but I am surely that you could already cope with our lesson for this kind of basic pattern, basic understanding how would the pattern in a sequence would be, alright? So this is how sequence and series would work, alright? So to continue, let us try another one, alright? So let us write the first seven terms, alright? So first seven terms of what? This kind of sequence. This is our sequence, alright? So we have an is equal to 4n plus 9. So the first term would be 13, alright? So the second term would be 17. So if we get this second term, alright, so what we wonder that from 13 it was moved by 17. So we could see that it was added by 4. But before that, alright, before that, by not knowing what's the next term, we should still find at least another term for us in order for us to see what's the pattern in the sequence, alright? So the third term would be 21. So in this term, in these three terms, may I ask if what do you see? What pattern do you see? Right? So it was added by 4. The common difference, alright? So after we find the pattern, we could see or clearly see and know the difference, right? The common difference of these three would be 4. So let us check for the another terms, alright? 4, alright? We have 25, 5. We have 29, 6. We have 33. And the 7 terms are 37. So we have the common difference of 4. And again, the formula. Take note of the formula. Don't forget to take down notes. The formula a sub 2 minus a sub 1, right? To get the common difference. Alright, so let me erase first. Alright, after getting those one, no, as we could see, that is how we could get the term that we are looking for. Alright, alright, alright. So we have this one. So let us determine the rules for a sequence. So we have this kind of example, no? So the rule of on determining a rule for the n term. So we are to find the n term. A while ago we have the seventh term, the 10th term, no? But in this part we are to find the n term of this sequence, alright? So this kind of this one of the example on finding the n term, no? So aside from this one, we are to find what's the n term. So we have this kind of sequence, no? So let us try to have this kind of example, no? Alright, so alright, so for that, again I will be going back. So for this kind of scenario, no, in finding n term, we have a rule which is a sub n is equal to 4 raised to n, or 4 power of n, or 4 raised to n. Later on you will see and you will understand why this is the rule, no? So there is specific reason why this was happened, or why this given is like this, no? So at first, let us try to determine if the following sequence is or are arithmetic or geometric. All right. So I will be showing some of the problems. All right. And you will try to guess the answer. All right. So the first problem would be the sequence of 3, 8, 13, 18, 23. So in this problem, what would you see? Right? What did you see? Alright, so as we look at this one, first we get the what are the first thing we need to do to find the pattern. So the pattern that we found was to add it by 5, right? So add it by 5, and as we add the 5, we could say that the common difference of this given sequence is is 5, right? So after we get this common difference, all right, so we could get a 5, but the thing is, we should determine if the sequence is arithmetic or geometric or neither of the two, right? Or neither of the two, right? So how are you going to say if a given sequence is an arithmetic or geometric? All right. So any clue? Anybody? All right. So maybe some of you will be typing on the comment section right now. All right. So or maybe someone will share is fine, but in order for us to see if it is arithmetic or geometric, no? So let us try to answer first, no? The first answer in this first given problem would be arithmetic, no? And we say a while ago we answered it that common difference is 5. Though the question in our mind is why this given sequence uh is an arithmetic, no? Why this sequence is an arithmetic? So first, in our first glance, we could say nothing all about if it's whether what sequence would this be, right? So we could see, and we could say if our given sequence would be arithmetic or or geometric by this next example. So the next example would be, all right. So the next example would be 1, 2, 4, 8, 16. So in this sequence, what do you notice? All right. So a while ago, the given sequence was to add up, right? Add up. So in this given sequence, what did we do? All right. So multiplied by 2. All right. So we multiplied it by 2, right? So if we multiplied it, yes, each term was multiplied by 2. Alright, so if this sequence was multiplied by 2, each term, each consecutive term, if this sequence was multiplied by 2, so the answer, or if this in the given problem number 1, we could say that the common difference would be 5. Then how is the number 2? You could say that the common difference is 2. Is that the right answer? No, of course. We could say that the common difference it is because our formula in this kind of sequence would be a sub 2 minus a sub 1, right? But in this kind of form, if we saw a multiplication, we would actually what? We would actually a sub 2, right? What? Divided by a sub 1. Alright? So, that's the thing that we could see, right? In the way on how we multiply. And as you know, when you are going to check, right? So, when you are going to check addition, you need subtraction. That's why it's difference. But in the case of multiplication, when we are going to check multiplication, it would be what? Division, right? So would it be the common quotient? Is that the right form? So if we go back in our past uh, level or in past academic year when you were grade 9, there is a lesson in your uh, grade 9 about ratio and proportion, right? So when we are to divide a set of numbers or set of ratio, right, it is also formed as a fraction form, like 1 is to 2, right? Or 3 is to 4, right? So in ratio, it is formed as a fraction form as well, right? So in division as well, if we have this kind of fraction form, for example, 4 over 7, right? So if this fraction form, it is also could be derived in division if you are going to pursue it, right? So if we are to put this 4 over 7, it would be 4 divided by 7, right? So it is also uh, a thing for we could say that if this given number 1 we have common difference, then in number 2 we have common ratio. That is why we have this kind of fraction form, no? So we could say the common ratio would be 2. Alright, so the thing is, oh, Sir Jai, it is geometry. So the thing is, why is it geometric? Alright, so if we notice, no, we what we did in the first given is, what did we do? We did is we added, right? So in each term, it was added, no? And while in geometric, it is said, no? In geometric, in each term, it was multiplied or halved or divided by, no? In each term, no? So we could say that in arithmetic, it is commonly used that in arithmetic, the addition and subtraction are commonly used, right? While in geometry, the multiplication and division are commonly used, right? So that's the thing, alright? So you could, in this two given, we could already see what's the difference between arithmetic and geometric, alright? So if we could say that one, so let us try another problem, alright? So or another problem would be 24, 12, 6, 3, 3 has, and 3 short. So, in this given problem, what did you see? Alright, so what did we see? Alright, so let me have, alright. Mm-hmm. So, as we see the given first term, the first term would be 24, and the second term would be 12. But in the given in the pattern, right? A while ago we said that in finding the pattern, it would be nice if it would be three terms, right? So as we saw the third term, from 12 it was 6. So in these two pairs, what did we saw? The common difference. The common difference or the common between these two pairs, not 24, 12, then 12, then 6. The common with those and that two pairs is that the the following number or the following term was divided by 2, right? So it was divided by 2, or we could say if we divide a whole number by 2, therefore we could say again in geometry what are the things that we use, operation that we use. It is multiplication or division, if you will see, right? So if it's division, right, so it was half. So in division as well, a while ago, no, a while ago I already told what's their thing, no. All right, so what's their thing? The thing is, it is also related in ratio. right? So if that's the case, I'm sorry, if that's the case, what would be the thing? It would be geometric, alright? So it is geometric, alright? So the common ratio is one half, right? Oh, it's one half, right? If we half or we divided a whole number by two, it is also half, right? So in a pizza, right? In a pizza, if you divide it by two, you also half it, right? So it you just multiplied it by 2 or 0.5, right? So that's the thing, yeah, there is 0.5. Alright, but in this portion, we use fraction, right? We use fraction, alright? So now we could see on that in geometry, it really does, it really uses the operation of division or the multiplication. Alright, so yeah, okay, let's proceed. We have the fourth given. We have 55, 51, 47, 40, 43, 39, and 35. So what did we see? Alright. Mm-hmm. What did we saw? Mm-hmm. So, as you see, as we already tell or discussed a while ago, no, in arithmetic, the operation that are commonly used are addition and subtraction, right? So, aside from addition, we use also the subtraction, no, and if you will see, no, the first thing we need to do is to find the pattern, then the common difference, right? So in these two pairs, what are the first two pairs? 55 and 51. Then the second pair would be 51 and 47, right? So in these two pairs, what's the common difference? So what's the formula again? A2 A sub 2 minus A sub 1. Again, guys, if we could see a variable, then there's a small number below. It is called as sub. Alright. So the formula again, the formula for this arithmetic would be a sub 2 minus a sub 1. Right? So a sub 2 minus a sub 1, it would be negative 4. Alright. So negative 4. It was divided minus by negative 4. 55, sorry, 51 minus 55, it would be negative 4. Alright. So the common difference of this sequence would be negative 4, right? So it is arithmetic, alright? So how about number 5? 2, 5, 10, 7. Let me see. 2, 5, 10, 17. 17, right? Sorry, rather. 17. So if you will see, what is the pattern? So the first thing we need to do is to find the pattern, right? The pattern would be what? What did for each term, what does happen? What happened? The first term 2, it goes to 5. Then the second term 5, it goes to 10. So as we can see, if we are to use the second, would it be possible 5 over 2? No, 10 over 5. But if we are to use a sub 2 minus a sub 1, it would be 3. Alright. How about in 10? It will be 5. Alright, 3, 5, and 7. Alright, so if you could say 3, 5, 7, some of you may be already telling that in each term, no? In each term, it's consecutive numbers, no? The common difference of this one would be 3, 5, 7. And if you will see, it was added by odd numbers, if that's the case. So if we will say that it per term, for you to get the next term, will be added by the odd numbers, then each term should be added by all of the odd numbers. That's not that wouldn't be the best answer, right? So the best answer would be, we are to determine, again, we are to determine. So the answer would be neither. Why is neither? Neither between the arithmetic and geometric. Why? Again, we could see, no, we will see. All right, I will explain. So we could see that in arithmetic, no, there is always there's always a common difference. There's always a common difference, right? And while in geometric, all right, in geometric they have common ratio, and the common thing between the two is that in each difference and each ratio that they have in a sequence has their common similarities in each term, right? So in this situation, are 3, 5, 7 are common to each other? Right? No, it isn't common, right? So that's the case. So that's why we could determine that this sequence is neither an arithmetic or geometric. And as well, there is no common ratio and no common difference, right? Are you getting? Alright. Okay, so let us have the sixth given. Alright, so we have the sixth given. Let me erase this one first. Alright, so the sixth given would be 1, 4, 9, 16, 25, and 36. So what would you see? What do you see in this sequence? What pattern do you see? You have 1, 4, 9, 16, 25, 36. Alright, so if we have the first term, again, let's have the three terms first, no? So that's the thing we used to do. First term, it moves with fourth term. Second term, it goes to 4, right? Then from 4, it moved by, or it increases by 9. And as well, the 9 increases by 16. And if we will see, no, from 1 to 4, it was added by 3. Okay? By, but then, the 4, it was increased by 9. Then, the difference of these two, or these two, yeah, would be 5. And as well as for this 9 and 6, what will be their difference? Their difference would be 7 as well for the 16 and 25. The difference of this pair would be 9. And as well this one, 11. So in this pattern, we could say what? We could say what? The pattern would be neither, right? Their the sequence would be neither arithmetic or geometric. And we could say that there is no common ratio and or no common difference. Alright, from this a problem and these answers that we had now, how now I will be asking you, how would you define a sequence as arithmetic, and if the sequence is a geometric? Alright. So I will let you think. Alright, so I will let you think, like, how would you see this six sequence that we had, no, that we try to answer and try to guess, no, if this problem could be arithmetic or geometric. Alright, so let us have the first given, no. So in the first given, obviously we had the operation of addition, right? So we have addition, right? Then for the second problem or second given, it the operation that was used is multiplication, m or d, multiplication or division, right? So in here, addition or subtraction, right? So I could erase this one. All right. So for the third term, what did we do? What is it? It's multiplication and division as well. So for the fourth one, so let me see. For the fourth one, it is arithmetic. So in arithmetic, again, what operation do we use? Available this one. The operation that was used is addition or subtraction, right? Alright. So in this part, so how would you define um uh not to define, what did you notice? Yes, we could easily say that in arithmetic, um, they have common difference, while in geometric they have common ratio. And if you will see a sequence, they have common difference. We could obviously see that the operation that was used is addition or subtraction, while the geometric, it has common ratio, and the operation that was used or commonly used is multiplication or division. Aside from that one, did you notice from this four sequence? What did you notice from this four sequence? Right? So I will be telling you, I will be asking you, what did you notice? Right? And what did you notice to this four given sequence to their four answers? Alright, so let me know your answers. Alright, so if you have your answers or if you have your clarification or questions, you can put it on our comment section here in live. Again, reminder, I am watching at this moment. Even this is a recorded, alright? So I'm watching who are those people who are commenting. Alright? Alright. So we could see, no? We could see that in the first given, it is arithmetic. Yes, obviously it is arithmetic. Then the common difference is positive, right? While in the other arithmetic is negative, right? So as well as for the second geometry, yes, its common ratio, it's positive, right? While in the third given, yeah, it is geometric, but it is in fraction form. Or we could say that what? The lesser or the least, alright? The least value, or if it's negative, you can see in arithmetic, when the value is positive or it's greater, right? Positive is greater than negative is lesser, right? So if it's positive, we could see that given is what? Increasing, right? So you can see that from 3 it becomes 8, right? So it increased by 5, right? So from 8 it increased to 13, right? So as we follow through, we have this positive common difference, then the sequence is increasing. So therefore, if we saw a sequence that is increasing, we could say that it has positive common difference. While there, in other hand, there's arithmetic which has the negative 4, which we could see that the given sequence is decreasing, right? So from 55, it turns out to 51, right? So from 51, it turns out to 47, and so on, right? So as well as for the geometry, if you will see, the common ratio of them is a positive, which is 2, right? So we have this 2, and the common and the sequence are increasing or rising as well, right? So while we have this common ratio, no, common ratio of fraction form, we have a sequence that is decreasing. Why is it like that, sir? Sir Jai, that from the second given, the geometry, the whole number 2, it is increasing, while the geometric common ratio is 1/2, but it's decreasing. But the 1/2 is still positive, right? So you will be thinking of that one, no? But I will ask you, when you multiplied, alright, this is a great question. If you multiplied a whole number, uh, what do you call this one? Whole number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, to a whole number, the given value or the product would be a whole number. But how what happened to the product? The product is or was increased as well, right? But when a number was multiplied into a fraction, um fraction, most likely in a proper fraction, no? Proper fraction, most likely in proper fraction. If we multiplied it by a proper fraction, no, the sequence most likely is decreasing, right? But if you have like improper, like 9 over 4, like that one, you have 2 and 1/4 in that case. So you could have at least like uh the whole number was multiplied to 4 and a 1/2, like that one. That's the cases. So there's a lot of cases in uh geometric, but the as we notice, no, that's the only cases that we could see. It's positive, then it's negative, it's greater or lesser. All right, so in this case, no, we could now determine what is the difference between arithmetic and geometric. All right, so are we good? Are you still coping up with me? All right, so to continue, a while ago we defined what is sequence and series. So a while ago we have this sequence. We also defined that sequence is could be the sequence could be infinite or finite, right? So sequence would be could be infinite or finite. So if we say infinite, these are the examples, all right? So if we say finite, these are the examples. So for their definition, as we say finite, no, there is an end, or there is the period, or there is the last value of the given set or given sequence, right? So while in infinite, if you say infinite, there is an forever. Sana all, char. Yeah. So there is a forever, or it doesn't have an end, right? So that is infinite, and it is obviously that we say infinite is a continuous growing, continuous numbering or adding up or following set of subject, no, it's in general, no. So infinite, it is the other counterpart of infinite, no. So this is the example, and if we will see, no, there is an end in infinite. We have 81. The first term would be 1, but the ending term or the end term is 81, right? So while in infinite we have this 14, right, the first term, then the end term is continuous, right? So their given is obviously seen by their given sequence already, right? Infinite or finite. All right. So are you getting how is it? What's the difference, right? So it is super basic, right? So all right. So please take the notes again. What's about the definitions, all right? So some of the examples that would uh that might be on some quizzes or some activities, no, so please do take down notes, alright. So to continue, alright, so there are two types of sequence, no. A while ago we already tackled what are those two types, no. It is arithmetic and geometric, and we also um see or saw that in geometric it has common ratio, right? And in arithmetic it has common difference, right? So the examples are this one, no? In arithmetic it is increasing as we can see, and the common difference would in this form it would be 1, right? And in this form, the common difference in this form it is increasing, the common difference would be positive, and the common difference would be 10, right? So a sub 2 minus a sub 1, alright? So 10, 10, alright? 10, alright? So how about this one? You could see its difference. It's decreasing. So therefore, maybe the difference would be what? Would be what? Mm-hmm. It would be negative, alright? So it is like 0, negative, I'm sorry, 0, a sub 2 minus a sub 1. So a sub 2 minus a sub 1, it would be 0, right? Like 0, I'm sorry, a sub 2, 0 minus 3, it would be negative 3, right? So as well as this one, So it is increasing. So negative 3, right? As well as this one example. Now in common ratio, we multiplied it by 2, right? So a while ago we have those operations, right? How about this one? We multiplied it by 3, right? So 3. Alright. So how about this one? We multiplied it by we multiplied it by what? By 2. Alright. So may I ask you a question? It is increasing or decreasing? It is decreasing, huh? Even the value of the denominator is going up. It is decreasing, alright? So we know that in fraction form, if the denominator goes up, the values goes low, right? Alright. So to continue, so the next page, in the next slide, we have this arithmetic rule. No, so I want you to remember about this kind of rules. No, so we have this formula: a sub n is equal to a sub 1 plus n minus 1 times d. So we have the first term, which is a sub 1, all right, plus n minus 1. If we say n minus 1, n is the term, no? And the d is the difference or common difference, no? If you say a sub n, it is the value of the last term or the term that we are looking for, alright? So it is said that a sub 1 is first term, the n is the term that we are trying to get, no? So like the 10th term, like that one, then the a sub n is the value of the 10 term that we are looking for, like that one. Then the d is the common difference. That is in arithmetic, no? So let us try that one, no? We have 75, 25, negative 25, negative 75, negative 25, 125, no? So we are to find 100 term. That's why we have the formula. That's why you should take down note of this one, no? So we have the first term. What's the first term? 75, right? So the n is 100. That's the one that we are looking at. So it's 100, it's 75, right? Then what's minus 1, right? So what's the common difference? If we could see 25 a sub 2, no? A sub 2 minus 75. So we could say that it is negative 50, no? So mental math to be negative 50. So if you could say that 100 minus 1, it will be 99, right? So times by negative 50, right? Then you will add it by 75, right? Then we will have the answer of negative 4,875. Alright, so I want you to take note of the formula by which it is really important. Then if you will get the 100 term by manually, you will get a long time to get that one. Alright? Alright. So to continue, no? So let's try it with problem number 1, no? So suppose you are to run in 2 miles in a week. So let us have this given, no? 2 miles per week. Then you are planning to add a 1 half. So you are to add up, no, 1 half. So it will be 2.5, right? 1 half every week. Then the week that you are going to run in the end is 6 miles, no? So we have the given already. We have the first term 2 a1 a sub 1, right? Then common difference would be what? 1 half, right? 1 half. Then what's the n that we are find? That is the n, but we have the 6, so it is the a sub n, right? So what's the formula? The formula is a sub n is equal to a sub 1, right? A sub 1 plus what? Plus n minus 1, right? Then the difference. So if you will have that one, what is the solution? The solution would be this one, right? So it will be giving you already, so that you could have the another formula for the other rule, no? So the solution would be this one now, 2, right? So we have 2, the first term, Then the n is the one that we are finding, no? So it will be times by 1/2, then the 6. So in order for us to get that one, the first thing we need to do is what? Transfer this one. So it would be what? Minus, right? So positive to negative, it would be 4. 6 minus 2, right? 6 minus 2, then equals, right? So it will be 4. Then the given that will be left here is, first thing we need to do is to transfer, distribute. So it would be n 1/2, right? Minus. Minus what? 1/2. 1/2. Then minus. Alright. So after that one, what we could see that this one could be transferred here. So it would be 4 and 1/2, right? So we have left this one and this one. So in this one, we are to find the n. So what we are going to do is to cancel the 1/2, right? Cancel, 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 right? So also 1/2, right? Therefore, our n is 4. That's it. Alright? So that's how you get the n. Alright? So you're getting it already. Alright. So in here, geometric rule. So we have the formula of, take down notes, we have a sub n is equal to a sub 1. Alright? So we a sub 1 times the ratio. That's the one that I showed you a while ago. That's the one I am saying that you will see further, no? So a sub n is equal to a sub 1, the first term. Then the ratio, you already know that one. Then the n that we are finding. Then that's it. That's the formula. No, so let us try that one, no, to some examples. So we have the sequence of 4, 20, 100, 500. So the formula would be a sub n is equal to a sub 1, right, times r, then the upper part or the raised to n minus 1. That's the formula, no? Pardon with this one, no? It's a bit messy, no? Alright, so to continue, what's the first term? First term would be 4. And the ratio, how we determine? The thing that I say a while ago is the second term. What's our second term? This one, right? Divided by 4, right? So 20 divided by 4, it is simply 5. And if we could see that 100 divided by 20, it would be 5 as well. So our common ratio would be 5. Pardon. Alright, so we have 5. So again, what is our n? To determine our 10th term, right? So as we get that one, as we get the value, it would be a sub n is equal to 4 times what? 4 times 5 raised to what? Raised to 9, right? This one. So we get this first, then after we get the value of this one, then we simply times this one, and we got the value of a sub n. Alright? So with that one, no, that is how you get the, or how you use the rule for geometric. All right, so I want you class to take note of those two formulas, no, thus it will be it will have a big part through our next discussions and through our next lessons, no. And I want you that before we end our um lesson, our meeting for this moment, uh, I want you I want you to comment in our in this video, not in the live section. No, after this video ends, I want you to comment down below. No, that what are the things that you discovered. No, inputting what is your um section. No, 10C, 10C, then underscore class number. What's your class number? For example, class number is 00. Then full name. Alright, full name. Then after that one, you tell your reason below. Alright, so you tell your reason, like what are your insights. What did you learn in this lesson? No, then I will be looking who are those following the instruction and who are those really watching this video. For this is a confirmation for me who are those people who really deserves to give a better grade, for which I could see who are those students who really follow the directions. No, it's really important in our lives to follow the directions. All right. So before we end, I would like you to have those two, and don't forget to hit the like button. No, I'm what I'm saying is for you to have the last comment or on our this YouTube video. All right, not in the live comment, no, but in the comment section below the description box. All right, so if you really love this video or if you really liked this video, you learned about this video, you could smash that like button and you could subscribe also. All right, but I'm not really into that one. But if you really love this video, I'm hoping that you really learned. All right, so again, um see you soon with this kind of format, no? So for the following meetings or activities or rules or quizzes, no, we will be having this kind of format in YouTube. So welcome to my lesson and welcome to my teaching strategy for you to learn in online modality. So that's all. Thank you again, grade 10C. So you may now have this comment section. Thank you. Thank you for watching. Bye.